Hello guys, in today's class we shall discuss the topic performance of protective relays. Okay, so we know that backup relays will operate only when no primary relays operate. That is, if primary relays fail to operate, then only backup relay will come into picture. That will isolate the faulty part from the healthy part of the system. So as per this, relay performance is generally classified as correct operation, incorrect operation, as well as no conclusion. Okay, first one is correct operation. We shall see what exactly the correct operation is. Okay, the correct operation of the relay can be either wanted or unwanted. So usually what happens, sometimes relay operate and we desire that operation, or sometimes we don't desire that operation, means the relay operating will be fine. Sometimes we want our relay to operate and sometimes we don't want our relay to operate. That's why it is given as correct operation of the relay can be either wanted or unwanted, that is desired or not desired. So the correct operation gives information about which all relays to operate, that is first one. Second one is, and none of the backup relays should operate so as to trip the faulty part. Second one. Third one is proper isolation of faulty area in expected time. So first one is, let us glance at once again. So what all relays should operate, that is primary relays should operate at the first. Second one is, what are all the backup relays should not operate so as to trip the faulty part. Third one is proper isolation of faulty area in expected time. Okay, there are three things which come under what? Correct operation. There are very less such operations where the operation of the relay is correct but they are unwanted, that is undesired. Okay, they are very less. Usually all of them are what? Wanted, okay, as well as correct, but very less in such operations are there where there is correct as well as unwanted. Okay, second one is incorrect operation. See, sometimes what happens in the power system, sometimes it fail to work. That is, a failure in power system may cause incorrect operation of the relays. Okay, so due to this what happens? Our system will not work properly. So reasons for such failure in isolating the faulty part of the healthy power system may be due to the misapplication of relays. Second one is incorrect settings. Third one is personal errors. Fourth one is equipment malfunctions. These are the four reasons why our system may fail. Okay, so such things have to be avoided so that we get all the correct operation in the system. These are four things: misapplications, incorrect settings, personal errors, as well as equipment malfunctions may cause failure in the power system and which may lead to incorrect operation of the system or incorrect operation of the relays. Okay. Third one is no conclusion. See, as the name itself indicates, no conclusion is the case where one or more relays of the power system fail to operate or do not operate. So the reason is suspected that many of the cases no conclusion is a result of personal involvement, where human beings where they personally involved to set the system or any set the values and all. That is one of the causes where no conclusion case may arise. Or sometimes what happens, the whatever the errors which resulted by the system will be not reported itself sometimes. Okay, so such times also what happens, we don't get any conclusion out of the system. So nowadays what happened, modern equipments using oscillograph may indicate the possibilities of no conclusion. Okay, so by using such things what happens, the reason for no conclusion can be also fetched. So this is what we have with the third one. Okay, now let's see the classification of protective relays. So the classification of protective relays are based on technology, generation of development, function, as well as comparators. At the first, let us see classification based on technology. Okay. See, based on technology, again, the classification is made into again three types or into three parts. The first one is electromechanical relays. Second one is static relays. Third one is numerical relays. Now let us try to understand these relays one by one. At the first, we have electromechanical relays. Again, in electromechanical relays, we have two types. The first one is electromagnetic relay. The second one is the thermal relay. Electromagnetic relays works on the principle of electromagnetic attraction or electromagnetic induction. Let us see those. What is the difference between electromagnetic attraction as well as electromagnetic induction? Okay. So first of all, we shall discuss electromagnetic relays, which works on the principle of electromagnetic attraction. Okay. So we know that here this type of relays has armature in it, so which gets attracted by the electromagnet. Okay. Based off that, it is categorized under what? Electromagnetic attraction. So there is a strong attraction between electromagnetic as well as electromagnet as well as armature. Okay. Otherwise, one more type is there in that. So this is also categorized under the electromagnetic attraction itself. We have plunger as well as solenoid valve. So plunger will be moving to and fro depending upon the whether the solenoid is charged or not. So such types of relays come under what? Electromagnetic attraction type of relays. So where armature type is used. Okay. The second one is your electromagnetic induction. As the name itself indicates, it works on the principle of electromagnetic induction, Faraday's induction. Okay. So here we have one electromagnet as well as and one moving part. Okay. We have electromagnet as well as we have a moving part in it. So depending upon this, your electromagnetic relays work. Okay. Like moving part in sense, it may be a disc or something, aluminum disc and something. So it starts to rotate whenever the actual quantity exceeds the reference quantity. In that case, such type of relays are called as electromagnetic relays. And again, electromagnetic relays work, that is whichever the relay based on EMI, that is electromagnetic induction relay, works on AC quantity, whereas your electromechanical attraction type of relay works on both AC as well as DC. Okay. So both type of relays operate using mechanical forces. So their torque is developed. So due to this, what happens? There creates a mechanical force, and due to this, both electromechanical attraction relay as well as electromagnetic induction relay works. Okay. Now coming to the static relays. This was the second one based on the technology. Okay. Now let us understand what static relays are. Okay. Static relays usually consist of transistors, ICs as well as diodes and also other electronic components. And again, there is a comparative circuit present in the static relay, which always compare two or more currents or two or more voltages and gives an output which is applied to a hysteresis circuit or electromagnetic relay. And again, after giving the signal to the electromagnetic relay, it finally closes the contact, and depending upon the nature of the relay, circuit is tripped. Okay, circuit is tripped. So here we have one more advantage here, that is in the static relay, that is it consists of low burden on the CT and VT, and also it has fast operation. Okay, it has low burden in CT and VT, fast operation, as well as any absence of mechanical inertia like we had in the electromechanical relay. So there is no any such mechanical inertia, and there is no any contact trouble, and or sometimes there is a contact trouble, means even after trip signal, contacts may not be proper in your electromechanical relay. These are the advantages which overcome such relays, and also they have long life and less maintenance. Okay, and so that's why static relays have proved superior than that of electromechanical relays. Now let us see what low burden means. Okay, having low burden. Low burden is nothing but it is always with respect to the output or secondary. Usually low burden, or let us first try to understand what burden is. Let us again see what is low burden or very high burden means. Okay. Burden is usually expressed in terms of volt ampere with respect to second words. In simple words, if I want to say means it is the load connected to the current transformer at the secondary side. Okay, it's simple words. It is the load connected to the current transformer in the secondary side. Usually, for example, like I said, burden is expressed in terms of volt ampere. For example, you may have 10 volt ampere, 15 volt ampere, or 20 volt ampere, or 30 volt ampere as a burden value on the secondary side of the current transformer. So, low burden in sense what? Lower values of the volt ampere values. High burden means higher volt ampere values of the relay. Okay. Now, coming to the second one, that is third one, that is numerical relays. So, these are the relays which take samples of AC quantity in digital form through data acquisition system and process them using suitable algorithm. Okay, so to calculate any fault values and trip, so what it does, it will take the samples of AC quantities in the form of digital through data acquisition system, and so as to calculate the fault values and finally trip the faulty part. Okay, so at present we have microcontroller as well as microprocessor based numerical relays. Okay, and these numerical relays, that is based on microcontroller as well as microprocessor, are economical in nature. They are powerful, sophisticated numerical relays are also available today in the market. Because of the tremendous development and all, what happened? They are used more. Okay, and again due to their errors being less. The main features are they are economic, their compactness, their flexibility, as well as their reliable and self-monitoring and self-checking capability. Okay, and also better than the convention relays. So due to this, what has happened? They are much more improved than the convention relays because of this fine features. Okay, so this is what we have with the numerical relays. Okay, and one more thing, these relays sometimes are also called as digital relays. The digital relays as well as numerical relays are used interchangeably. Now let us see the classification of protective relays based on speed of operation. You can say again based on their operation, speed of operation, again they are classified into 4 parts. One is instantaneous, second one is time delay, third one is high speed, and fourth one is ultra high speed relays. At the first we have instantaneous relays. As the name itself indicates, these relays have no any intention time delay. Means as soon as it is called, it will trip the system. So these relays will operate as soon as any decision is made, very instantaneous. Okay. Second one is we have time delay relays. As the name itself indicates, time delay in sense what? These relays have some intended time delay introduced between the relay decision as well as initiation of trip signal. Between that some delay is given so that these relays will work after certain delay. Third one is high speed relays. So again name is indicating high speed in sense what? It is more speed than the instantaneous relay, that is it works at the rate of 60 millisecond. So within this duration of time your relay will operate less than the 60 milliseconds. So fourth one is again ultra high speed. Okay, again due to this working and all, it is not categorized under standard relay, but these relays will operate even less than 5 milliseconds. Okay. Next one is we have classification of protective relays based on their generation of development, like I said earlier. Okay, so we have 3 generation here, the first generation, second generation as well as the third generation. In the first generation we already discussed, that is electromechanical relays, which includes electromagnetic relays, as yes or not. The second one is static relays, which use of transistors and other electronic circuits, and third one is that is numerical relays. Okay, which is also called as digital relay, and again it is having more compactness as well as economy when compared to the other type of relays. Okay.